Hi everyone, today we are going to learn how to graph quadratic functions in Vertex or Intercept form. Before we get started, let's review a little bit of what we already know about standard form, and I would like you to please identify the vertex of the following equation. Y equals 4x squared minus 16x plus 3. Please use what you learned in our previous lesson to help you identify what that vertex actually is. Pause the video as you work on this problem and then restart it to see how well you did. All right, so in order for us to identify the vertex when it's written in standard form, we first need to identify the x part. And the x part, remember, is from x equals the opposite of b over 2a. So it's very helpful to identify your a and b value in this problem. So my a value is 4. And my b value is equal to negative 16. And I'm going to use the opposite of b over 2a. So the x part of my vertex is equal to the opposite of negative 16, which is positive 16, divided by 2 times 4. So this is going to be equal to 16 divided by 8, which is 2. So I find that x is equal to 2. Awesome. In my vertex, I have the ordered pair 2 comma something. So now I'm going to take this value of 2 and plug it directly into the equation to find what y is. So now I'm going to write y is equal to 4 times 2 squared minus 16 times 2 plus 3. You can put this entire expression into your calculator exactly as you see it, but please make sure that you use parentheses. And when you do that, you end up with negative 13. So our vertex in this case is 2, negative 13. Hopefully you got this answer correct, because being able to identify a vertex is going to be very important throughout this entire chapter. Our vertex, identifying the vertex, is going to be different with all of our different ways that we can write a quadratic formula or quadratic function. There are 3 ways. There's standard form, vertex form, and intercept form. And in this lesson, we're going to be talking about vertex form and intercept form. So our learning objective for today is for you to be able to say, I can graph functions written in vertex form using a transformation table based on the parent function. And I can graph quadratic functions in intercept form by identifying the x-intercepts and the vertex, among other points. So today we're going to start with reviewing some information about the parent function. And our parent function, once again, is y is equal to x squared, or f of x is equal to x squared, depending on if it's in function notation. And what I have drawn here is a very quick sketch of what the parent function looks like. The parent function, once again, is pointing up. It has a dashed line going through it, which is our line of symmetry. And in this case, when we talk about vertex form, our line of symmetry is actually going to be the h value. So x equals h is always going to be your line of symmetry. Remember that line of symmetry is also known as the axis of symmetry. So you might see those words go interchangeably. So LOS and axis of symmetry, AOS, same exact thing. The ordered pairs are going to be important for you to know, because you're going to use these in your table. Because we are going to create a table, a parent function, reflection, stretch translation table in this section whenever we're working with vertex form. So I'm going to say you're going to use these values in your table. All right, so you just need to know that negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. These are your ordered pairs. Do you have to use every single one every single time? No, and I'm going to explain in just a moment how many ordered pairs you need. But you should be able to identify those ordered pairs on your graph. The domain is still all real numbers. That means that every single x value can be squared. Every single x value is part of this function. So once again, this symbol means all real numbers. Your range represents all of the y values that your function touches. And with respect to our parent function, it's going to be y is greater than or equal to 0. Greater than or equal to indicates that the graph is pointing up. If the graph is pointing down, then that means that you'll have a less than or equal to. the number that you use is always the y part of your vertex. So that is just a very brief overview of our parent function. And you'll need to know about the parent function and what it looks like, because we're going to transform it using our vertex form. Now, vertex form is y equals a times parentheses x minus h squared plus k. It's a very similar structure to our absolute value function that we already talked about. The graph of y equals a times x minus h squared plus k is also a parabola, but it might be located in a different spot. It might be our vertex might be a different number. Our graph might be wider. It might be narrower, indicating a vertical stretch or shrink. It might be pointing upside down. And this is where we're actually going to be analyzing the transformation. So once again, if you have an a value that is negative, that means the parabola has been reflected over the x-axis. So in your reflection column, if we were to have a table of values, which we created a table similar to this before, we would have a parent function table where you would identify the ordered pairs of your parent function. And I'm going to say that you're going to want to choose 3 ordered pairs. So you're going to want to choose 3 points, and those points should be ordered pairs that represent the negative side of the graph, should absolutely have 0, 0. And then choose an ordered pair that represents the positive side of the graph. And I would also recommend that you choose like ordered pairs, meaning if you choose negative 1, 1, 0, 0, and 1, 1, they match each other. Or choose negative 2, 4, 0, 0, and 2, 4. Be strategic about the ordered pairs that you select whenever you put them into your table. Next, the next column is reflection. And in this column, you're going to actually have a reflection only if your a value is negative. So if a is negative, then what you're going to do is you're going to multiply all y values, because all of your y values will become the opposite. So if a is negative, you're going to multiply all of your y values by negative 1, indicating that we have a reflection across the x-axis, indicating that all of our y values will now become negative. But if your a value is positive, we're going to write nothing in that column. We literally write the word none. We don't have anything going on in that column. S represents stretch or shrink, and that's what the next little sentence is talking about. It says if the absolute value of a is greater than 1, then that means the parabola has been expanded vertically. We also call that stretched vertically, indicating that we have a skinny graph or a narrower graph. Or if the absolute value of a is less than 1, then that means the parabola has been contracted vertically or shrank vertically. So this is called vertical shrink. So you can call it shrink or shrink. If you have an a value, so if the absolute value of a is not equal to 1, and it's some other number, we're going to multiply all of our y values by the absolute value of a. And the reason why is that we work with the absolute value of a is because we've already addressed the negative in the reflection column. The stretch is going to be the other piece. So if you're working with an a value that's negative 2, the negative piece will be in the R column, the reflection column, and the 2 will be in the stretch column, indicating that we have a vertical stretch or shrink. If the absolute value of a is equal to 1, you will write nothing in this column. So if the absolute value of a does equal 1, write the word none in this column. There is no stretch or shrink. It's going to be the exact same width as the parent function. Next, we have the parabola has been translated h units and vertically k units. This indicates that we have shifted or translated it or slid it to the right, left, up, or down. And that's going to indicate your vertex. Your vertex is going to be hk. Now, in the equation, h is always the opposite of what you see. And K is always going to be exactly what you see. So when it comes to H, if inside of the parentheses you see a positive number, like x plus 2, that means that your H value will be negative 2. If you see like an x minus 3, the opposite of a minus 3 is a positive 3. Our H value would be the number 3. So it's always the opposite of what you see. Your K value is exactly what you see. What number are you adding or subtracting on the outside of the parentheses? It'll always be exactly what you see. And the values for your vertex are going to be addressed in the translation column. You will always take your X values and add your H, and take your Y values and add K. And I'm going to write plus signs there because we will, if your H or K value are negative, then adding a negative is the same as minus. Sometimes you don't have a translation, and if that's the case, then you would write none in that column. Typically, though, if we're working with problems like these, we will have some kind of translation. And so that's what you would do in this column. X plus H and Y plus K. And it's always based on your previous ordered pair. So whatever column that you were working with last, those are the ordered pairs that you're going to be working with. The axis of symmetry, or your line of symmetry, is always an invisible, is always a vertical dashed line that's going to be intersecting the vertex. And because it's a vertical line, vertical lines are Vux situations. Vertical line means Vux. Vertical line, undefined slope, x equals a number, and x is always going to equal h. So there's no equation that you really need to work out. Just identify the x part of your vertex. So it's always the x part of your vertex. And that is going to be your line of symmetry. So for these types of graphs, once again, we'll be working with that parent function, reflection, stretch, shrink, translation table, and I will be requiring it on your test. So let's go ahead and look at example number 1. For example number 1, it says graph y is equal to negative 1/2 times x minus 3 squared minus 5. So the first thing that we're going to do is recognize that we have a vertex form given to us, and we're going to create a table. PF represents parent function, reflection, stretch, shrink, translation. When you're picking out your ordered pairs, a strategy is to look at the fact that our A value is a fraction. And I would strongly recommend that you select ordered pairs with X values that are multiples of the denominator. So I'm going to write this out in words. Pick X values. From your ordered pairs that are multiples of the denominator. So what I mean by that is our denominator is 2. So I would recommend that you select maybe negative 2, 4, 0, 0, and 2, 4. Or you could even work with negative 4, 16, 0, 0, and 4, 16, because those X values are multiples of 2. Since you only need 3 ordered pairs, and we need to just keep this simple, I'm going to choose negative 2, 4, 0, 0, and 2, 4. Is there anything wrong with choosing negative 1, 1, 0, 0, and 1, 1? Absolutely not. But what you're getting yourself into is working with fractions. And sometimes working with fractions, it's a little bit easier to make errors. So I'm just trying to save you some time. Next, in this problem, our A value is negative. So we're going to split the negative 1/2 apart into 2 pieces. Negative 1 times a 1/2. So splitting it up into 2 pieces, the negative 1 indicates we have a reflection, and the 1/2 indicates that we have a shrink, because it is a number smaller than 1. So I'm going to, for my reflection column, I'm going to multiply all values of y for my previous column by a negative 1, because in this case we have a reflection. So I have negative 2, negative 4, 0, 0, and 2, negative 4. If I were to stop right here and plot these ordered pairs, I would be plotting a parabola that's pointing down. Next, stretch shrink. I'm going to multiply all of my y values by a positive number. So in your stretch column, we're always multiplying by a positive number. And in this case, that positive number is 1/2. It's the absolute value of A. So I'm going to take my previous column, so I'm ignoring my first column, and I'm always working with my previous ordered pairs, and I'm multiplying just the y values by 1/2. I'm not shifting this graph to the left or right yet, so I'm not going to work with the x values. So I have -2, -2, still 0, 0, and 2, -2. If I were to graph these ordered pairs, I would have a parabola that's pointing upside down, and I would have a wider graph than my parent function. And then finally, we have translation. And in this case, my h value is -3. So the opposite of -3 is a +3. So I'm going to have x plus 3. And exactly what I see on the outside is a -5. So I'm going to have y minus 5. And that's what I'm going to do with my ordered pairs, x plus 3 and y minus 5, because my vertex should be the ordered pair 3, -5, the opposite of what I see inside and exactly what I see on the outside. So I'm going to apply -2 plus 3, which is 1, -2 minus 5, which is -7, 0 plus 3 is 3, 0 minus 5 is -5, and 2 plus 3 is 5, -2 minus 5 is -7. I still have symmetry amongst my ordered pairs, and these 3 ordered pairs are the only ordered pairs that I need to plot. Cool. Before I even plot anything, there's 3 more pieces of information that I need you to be able to identify. The first is your line of symmetry. The second is your domain. And third is your range. Now remember that your line of symmetry is x equals h, so that's going to be x equals 3. So I'm going to go to where x equals 3, 1, 2, 3, and I'm going to draw a vertical dashed line. Next, I'm going to plot these ordered pairs, -1, I'm sorry, 1, -7, excuse me. And then 3, -5. And then 5, -7. I'm going to draw a smooth curve going through these ordered pairs. And there is my parabola. This parabola has a domain that will always be all real numbers. And because it is pointing down, I will have a range that is going to be y is less than or equal to, and it's still the y part of your vertex. And my y part of my vertex is -5. If we were to look at all of the ordered pairs of this parabola, all of the numbers will be smaller than -5. And because we have a closed circle, we're going to have an equal to symbol on our range. Please go ahead and pause the video and try example number 2 on your own. To get you started, this is going to be y is equal to 2 times x minus 0 squared plus 1. Whenever you don't see an h, we always assume that it is 0. So go ahead and pause the video, try this one on your own, and we will see how well you did. Okay, so the first thing that we need to do is we need to create our table. This is my parent function, reflection, stretch shrink, translation table. And we need to pick ordered pairs. So you can work with any of the ordered pairs. And in this case, because our a value is not a fraction, I would just make it easy on ourselves and work with -1, 1, 0, 0, and 1, 1. In this case, my a value is not negative, so that indicates that I do not have a reflection. So I'm simply going to write the word none. There is no reflection. A is positive. So that means it's going to be pointing up. So I don't have to do anything in that column. Stretch. Well, the A value is not 1, it's 2. So that means that I'm going to take my previous ordered pairs and I'm going to multiply those values by 2, my Y values by 2. So I'm going to end up with negative 1, 2, still 0, 0, and 1, 2. Translation. Well, in this case, my H value is 0, my K value is 1, so that means that all of my X values will be increased by nothing, they remain the same, and my Y values will be increased by 1, because my vertex is going to be located at 0, 1. So all of my X values will remain the same, and 2 plus 1 is 3, 0, and then 1, 0 plus 1 is 1, and then 1, 2 plus 1 is 3. I still have symmetry in my table, and these ordered pairs are the only ordered pairs that you need to plot. You also need to identify your line of symmetry, your domain, and range. So our line of symmetry in this case is going to be x equals h, and our h value is 0, so that's going to be x equals 0. So at x equals 0, I am going to draw a vertical dashed line. So even though my axis is on the y-axis, we still draw it in. And if it means that you need to get out of color so that you can actually see it, then that's what I need you to do. So I'm going to go to where negative 1, 3 is, 0, 1, and 1, 3. And I'm going to draw a curved U going through these points. And there's your graph. Please do not have your graph look like an absolute value. This is not a V, it needs to look like a U. When it comes to our domain, it's always going to be all real numbers, and our range is going to be based on the y part of our vertex. So since our parabola is pointing up, we're going to have a greater than or equal to, and the y part of my vertex is 1. So I'm going to have y is greater than or equal to 1. Next, we're going to talk about intercept form. An intercept form helps you to identify the x-intercepts easily. Sometimes it's referred to as factored form as well. So if the graph of a quadratic has at least one x-intercept, so if it has one x-intercept, then the function can be represented in intercept form, also known as factored form. But we all know that quadratics, not all quadratics functions can be factored, so not every function can be written in intercept form and the way that I'm going to talk about it. The intercept form is going to be f of x is equal to a times x minus p times x minus q. The a value that is in every single form is the same exact a value with the exact same properties. If a is a larger number, then we'll have a skinny graph. If a is a smaller number, we'll have a wider graph. And if a is negative, well, our parabola will be pointing down. So it carries the same properties. P and Q represent different things. The x-intercepts are going to be P, 0 and Q, 0. They represent your x-intercepts. It's where you let each parenthesis equal to 0 and then you solve for it. Or it's the opposite of what you see inside. So whenever you see parentheses, always think opposite of what you see. So I'm going to say that P and Q are always the opposite of what you see inside. So it's always the opposite of what you see. For this graph, just like we had it with a standard form, you will be asked to identify 5 points. So this is the one where you will need to find five key points. And on your test, I will have what I'm looking for spelled out for you so that you can identify your information easily without forgetting anything. So the first thing you're going to need to identify are your x-intercepts. That's always going to be first. Then the axis of symmetry, LOS, represents the halfway point. So your line of symmetry is halfway between P and Q. In other words, your equation for the line of symmetry is going to be the average of your x values since it's directly in between. And so that average is going to be x equals P plus Q divided by 2. It's the average of your x values. So if you look at this graph, we have P and Q, and they are going to be essentially equidistant from each other, and your vertex is going to be the average. That x part of your vertex is going to be the average of your x-intercepts. Next, if the graph opens up if A is greater than 0, and it opens down if A is less than 0. So if we have a positive graph or a positive A value, it opens up. And if our A value is negative, then it opens down. The other point that you're going to need to identify is an OPT and an RPT. So the points that you need to identify are your x-intercepts, your line of symmetry, which our line of symmetry, once again, in order for us to identify our vertex, it's always our line of symmetry x, which is going to be P plus Q divided by 2, and you'll take that number and plug it in to find what y is. That's your vertex. Then you'll need to identify an OPT and an RPT. An OPT, remember, is a point where you personally select an x value that has not been chosen, and then we count on the other side of the line of symmetry to find what your RPT is. Okay. Let's go ahead and get started. So number 1, we have f of x is equal to 2 times x minus 4 times x plus 1. So the first thing that we need to do is we need to identify what our x-intercepts are. And in this case, the opposite of a minus 4 is 4. So I have x equals 4. And the opposite of a plus 1 is a minus 1. So I have x equals negative 1. So these will produce the ordered pairs 0, will produce the ordered pairs 4, 0, and negative 1, 0. So these 2 points are going to be the first 2 points that we plot. So I'm going to go to where 4, 0 is, and I'm going to go to where negative 1, 0 is, and I'm going to plot my x-intercepts. Step number 2 is we need to identify our line of symmetry. So remember that your line of symmetry is x equals P plus Q divided by 2. My P value is 4 and my Q value is negative 1. So I'm going to average these values. So x is equal to 4 plus negative 1 divided by 2. So that's going to be equal to 3 divided by 2, which in other words is 1.5. So x equals 1.5 is going to be equal to my line of symmetry. Always rewrite it as an x equals equation because it represents a line. So I'm going to go to where 1.5 is, and I'm going to draw a vertical line, vertical dashed line going through 1.5. Next, I need to identify my vertex, and my vertex is going to be located where x is equal to 1.5 because it always goes through my line of symmetry. And now I need to substitute 1.5 into my original function in order to find what my y value is. Now, if it will help to rewrite this equation as y equals 2 times x minus 4 times x plus 1, that's perfectly fine. It still helps you to identify your y. You don't have to make that change. So I'm going to write y is equal to 2 times 1.5 minus 4 times 1.5 plus 1. You can put this expression into your calculator exactly as you see it. And when you do that, you end up with the value of negative 12.5. So I have the vertex of 1.5, negative 12.5, and I'm going to plot my vertex. So here's where 12.5 is. Now the last thing that you need to identify is an OPT and an RPT. Your OPT represents one other point that you personally choose the X value. So I would recommend that you choose an X value that's relatively small. So you choose X. We always have to choose an X value that has not been used. So let me tell you what's out. You cannot use 4, you cannot use -1, and you cannot use 1.5. So pick something else. Maybe the number 0. 0 is a pretty easy number to work with. Or work with the number 1. So if I were to let X equal 0, I would plug it in and I would go Y is equal to 2 times 0 minus 4 times 0 plus 1. You can put this expression into your calculator exactly as you see it, and you will end up with -8. So 0, -8 is your OPT. And I'm going to plot it. We also need to identify an RPT. That means reflection point. And that RPT is going to be equidistant on the other side of the line of symmetry. So 0, -8 is 1.5 units away from the line of symmetry. So if I counted 1.5 units on the other side, this is located at 1, 2, 3, -8. There's my reflection point. I have 5 points, so I'm going to draw a smooth curve going through these points with arrows at both ends. And the last thing I need to identify is my domain and range. So my domain, that's easy. It's always going to be all real numbers. I can always square any number. My range is going to be based on the y part of my vertex. So since the y part of my vertex is -12.5 and my parabola is pointing up, this is going to be y is greater than or equal to -12.5. I would like you to please go ahead and pause the video and try the next one on your own. I'm going to get it kind of started for you because it's not necessarily written in a traditional way. Whenever you see just an x by itself, what this means is y equals -x minus 0 times x minus 4. So once again, please pause the video and try to graph this problem on your own. And when you have an answer, please restart the video and we'll see how well you did. Okay, so the first thing that we need to do whenever we're working with intercept form is find the intercepts. So I'm going to find the x-intercepts. So in this case, my p-value is equal to 0, so the opposite of what I see is 0. And I also have x is equal to 4. So that means that the ordered pairs 0, 0, and 4, 0 are going to be my x-intercepts, and I'm going to plot those. So that's 0, 0, and 4, 0. Next, I need to identify my line of symmetry, and my line of symmetry is always the average of my x-intercepts. So that's going to be x equals, this is my p-value and my q-value, and averaging these numbers, 0 plus 4 divided by 2, is going to be equal to 4 over 2, which is 2. So x equals 2 is my line of symmetry. So I'm going to go to where x equals 2, and I'm going to draw a vertical dashed line. Next, step number 3. I need to identify what my vertex is. Well, I already know half of it. I know that 2 is my vertex, x. I just need to find what y is. So I'm going to write y is equal to negative parentheses 2 times 2 minus 4. So I'm just plugging this 2 directly into this problem. And I'm going to enter it exactly as I see it into my calculator. And I end up with my y part equaling the number 4. So I'm going to go over to 2 and up 4. Cool. Next, I need to identify an OPT and an RPT. So my other point, I cannot choose an x value that is 0, 4, or 2. So I need to pick something else that's easy. So I'm going to choose the number 1. And I'm going to plug 1 directly into my function. And I'm going to write y is equal to negative 1 times 1 minus 4. And if I put this expression into my calculator exactly as I see it, I'll end up with the number 3. So I'm going to plot 1, 3. 1, 3 is 1 unit away from my axis of symmetry, so I'm going to plot 1 point on the other side. And that ordered pair is located at 1, 2, 3, 3. So my RPT is located at 3, 3. That's my reflection point. I have all of my points, and now I can draw a smooth curve going through these points. Awesome. There's one last thing that we need to identify, and that is our domain and range. My domain in this case is always going to be all real numbers, and my range, well, in this case, my parabola is pointing down, which it's supposed to point. My A value is negative. That feels right. And I have y is less than or equal to the y part of my vertex, which is 4. And that is the end of this lesson. If you have any questions over how to graph a parabola in vertex form or intercept form, please send me an email. Otherwise, I hope you have a wonderful day.